Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So, my name is Neeraj Kheria, and I've been working in this IT industry for more than 13 years now. So, now, as a part of the session here, so we are going to discuss on the concept for Java OOPS, how the OOPS concept is set in Java platform. All right, so let's get started. So the main agenda in this workshop for today is we are going to focus on the OOPS concept in Java. So we are going to talk about the object-oriented programming concepts, OOPS versus procedural programming, and different concepts available in OOPS. And then we are going to discuss on the concept for inheritance, polymorphism, and then we are going to discuss on abstraction and encapsulation one by one. So we know that object-oriented programming is a programming style which is associated with the concepts like class object, inheritance, encapsulation, abstraction, polymorphism, and the most popular programming language like we have Java, C++, C, Ruby, they all follow object-oriented programming structure. So if we talk about object-oriented programming, then what exactly it is? So object-oriented programming refers to a type of programming in which programmers define the data type of a data structure and the type of operations that can be applied to the data structure. Now, as Java being the most sought after skill set, we will be talking more about object-oriented programming concepts as we proceed further in the session. And an object programming, or you can say an object-based application in Java is based on declaring classes, creating objects, and again, defining the entire structure so that multiple objects they can converse with one another, right? So basically, we talk about the objects, and again, here we have real-world entities that has their own properties and behaviors, and then we have classes, like we have the blueprint in which an object properties and behaviors are decided. For example, let's say now if you talk about classes here, now class can be for any animal, right? So here the class is for dog. Now we have different breeds of dog. So breed, size, age, color, these are all the properties available for a given class. So they all have a common characteristic that it means they all are dogs. They all have four. Again, they all walk on four, and then they have multiple properties because we have different breed, we have different size, age, and color. And then we also have different behaviors, right? Like we have eat, sleep, run, and bark. And these all are a part of the same class itself, correct? So you can see here for different values of data members, like we have breed, size, age, and color in Java class, we will be getting a different dog object because it can be know that for different properties we will be having different sets of dog defined. Then we have OOPS versus procedural programming. Let's discuss on that. There are multiple components available in OOPS as well, right? For example, here we have polymorphism, we have abstraction, we have encapsulation that we are going to discuss step by step. And if you talk about the comparison, that means if you talk about how OOPS compares with the procedural programming, then we can see here now in object-oriented programming, we follow the bottom-up approach, whereas in procedural programming, we follow top-down approach. And then we have, again, if we compare this based on the objects, then here we know object-oriented programming is focused on object because each and every components, they are divided into different objects, whereas in procedural programming, we have everything divided under functions, right? And then if we talk about if we talk about objects, and again, we know that in OOPS, concepts of objects and classes are introduced, and that's why we have all the main components divided into objects, which are going to be an instance of a classes. Whereas if we talk about the procedural programming, then now the main program is divided into small functions, and they all are going to be treated like a separate program for individual smaller programs. And then if we talk about access modifiers in OOPS, we can say in OOPS, access modifiers are introduced, namely as private, public, and protected, whereas we don't have any modifiers available in procedural programming. So if you are looking to enhance the security of the program, then we can use multiple access modifiers that is only available in object-oriented programming approach. And next we have objects can move and communicate with each other through member functions. And due to abstraction in OOPS, data hiding is possible, and hence it is more secure than the procedural programming. On the other hand, the procedural programming is less secure as compared to OOPS, right? And this is the main comparison between procedural and object-oriented programming approach. All right, so next, let's discuss on the concepts of OOPS. So basically, OOPS have four different components available. We have inheritance, polymorphism, abstraction, and encapsulation. So these are the building blocks of OOPS concept. And now let's talk about each and every of them one by one as we proceed further. So there are multiple advantages also of using object-oriented programming approach. So basically, it improves the productivity during the software development. It gives us a better, or we can say better and improved software maintainability. It allows us to work on faster development sprints where we can break down the entire code into smaller components, and that way we can bring down the cost of development at a much, we can say, at a much lower scale as compared to other approaches. And then it offers a high quality software into both in terms of the functionality and in terms of security as well. So the first thing that we are going to discuss is inheritance. So in OOPS, a computer program is designed in such a way where everything is an object and interact, and all the objects are going to interact with one another. And inheritance is one such concept where the properties of one class can be inherited by the other. So it helps us in reusing the code and establishing a relationship between different classes. So for example, let's say if we can see up from the image, we have animals, and then now animal is what? Animal is considered to be a class here. And in animal kingdom, we have multiple type of animals. Like we have mammals, we have reptiles, we have amphibians, and then we have birds. Now, they all have a common characteristic. That means they all belong to the animal family. So that's why they are all sharing the same class as animal, correct? Now let's say if we pick up any specific type here as mammals. Now, in mammals, horses, whales, human beings, monkeys, they all are part of mammals, right? Because they all share a common characteristics, correct, for mammals. And again, we can segregate them further. So basically what we are doing, we are trying to inherit one property of a class in all the other objects, or we can say all the other components in that class itself to improvise the functionality. Because again, suppose if a property has been defined in a class or in a subclass, then that can be easily carried away to all the child components as well. So every child is going to inherit the properties from the parent component, and that's how we can make sure that we don't have to rewrite the same thing again and again. We can easily inherit those components automatically by referring, or we can say inheriting by the parent itself. That's how it works here. All right, so here we have the super or parent class, and then we have the child class available. Next, we have, now in case you want to use it, then the syntax for us, we have to define the class, the subclass, and then we have to use extend superclass. So basically here we have to define which one is going to be our superclass from where we are going to inherit all the other classes. And the main advantage of using inheritance is it offers code reusability, right? So we can make sure that the code the same, we have to write the code only once in the parent, and then we can reuse them as and when required in any child component we want. Again, it can be extended to multiple classes, and then we can use it for overriding methods as well, and for adding data from one class to the other if we don't want something to be visible to all the other child classes as well. And then we can also make use of inheritance. And now if we talk about a type of inheritance, then there are three main types of inheritance available. We have single, multi-level, and then we have hierarchical. So in single inheritance, one class inherits the properties of the other. For example, we have class A. So class B is going to inherit only from class A. That's how it is structured. So this will in turn out, basically, it enables a derived class to inherit the properties and behavior from a single parent class. As you can see, class A. So this will in turn enable code reusability as well as add new features to the existing code. So here class A is our parent class and class B is our child class, which is going to inherit the properties and behavior of the parent class defined, right? Same way we have multi-level inheritance. Now in multi-level inheritance, when a class is derived from a class which is also being derived from the other class. For example, we can see class C is currently inheriting from class B and class B is inheriting from class A. That means in turn, class C is going to inherit every property defined in class B and as well as in class A, because class B itself is inheriting from class A. So whatever is in class B, that means class B components plus the components of class A, they are going to be inherited by class C. So this type of inheritance is called as multi-level inheritance. And then we have hierarchical. So when a class has more than one child class, for example, here we have parent as class A, and now we have multiple child components, class B, class C, and class D. They all are inheriting from the main class A, and this is called as hierarchical. So now we are going to work on Eclipse. So now on IntelliJ. So here we can simply create a new project from scratch. We can define the Java runtime that you are going to use here. Whatever runtime we want to use, we can define it. And then we can use any of the templates when we are creating it. We can give it any name. Let's say we name it as Edureka itself. So IntelliJ is offered as a community version as well. That means if we have a requirement for building multiple commercial projects, then we can go for enterprise, or we can go for community edition, which is good for developers or those who are just starting their journey on Java development. And we can use Eclipse, we can use any other editor as and when required. It is not mandatory that we have to use IntelliJ. We can use anywhere. So let's say here from this link. So here we have to click on download, and then we can choose the community version, and then we can click on download. And then we can start working on a new project altogether. So now we can define any class if we want. For example, suppose here we can create a new class, and let's say here we define the class, suppose let's say car itself. So here we can define car. So here we have a new public class defined as car, and then now let's say here we can define not a public here. Let's say we only define a simple class here for now. Now here we can define a protected string. For example, here we can define a protected string. And I suppose here we are going to define it for brand. And suppose here in terms of brand, we can define any value. Let's say here we are going to call the brand for suppose as Mercedes. And here we can define Mercedes. And then we can define public void name. Suppose now this can be any property. For example, this can be any property that we want to add here. Suppose here we have public void horn, a simple class here. So here we can define horn itself, and then we can define the voice, okay, that what kind of sound it is going to produce. So here we have system.out.println, and here we can define suppose honk itself, a simple sentence, whatever we are going to print here. Now once we are done here, we can create another class. So now we can create another class here. So let's say here we define class. Now here we are going to create a class here where we are going to create, suppose I say something for an E model. Suppose here we had defined a class with the name of S model itself. So here the class has S model. Now we want this one to extend the property. Now we can define extends. So whenever we are trying to inherit something here, we can define extends, and then we can define which class it is going to extend. This is going to extend the class defined as car itself. Let's capitalize this one. So here we can define it is going to inherit the class defined as car. And then we are going to define any kind of statement. So whatever has been defined here, this is going to be fetched automatically when we have applied the inheritance here. All right. And then we can define other components. For example, here in here we can define other components. Suppose here we want to specify the exact model here. So for example, suppose here we want to specify the exact model here, then we can define the model name, and then we are going to work on. For example, here we can define private string, again a private string, and then we can define model name. Now inside this model, again, we may have different model, may have multiple models available, like we have 350i, and this is again if we can say a different model, and then we can define public static void main string argus. Now when we define the string argus component here, then we are going to specify. Now here we are going to create a new object. So here we can define a new object that we are going to create. Let's suppose here we are going to make use of simple s model. From s model itself, let's suppose here we are going to create model number, suppose as model itself, and then here we are going to create new s model component, and then we are going to simply call the horn section that we have specified earlier. So for that we can simply define from the object that we have created here, so from model dot honk, because again this is where we have inherited this property here, right? So here we can define model honk, and then we are going to call it. So basically here we are going to call the honk method that we have specified earlier. So this was all. So this was the honk method that we defined here, that we specified earlier here, right? And then we can define the display. Now suppose I say here, once we are done, we can simply use a statement as system dot out dot println, and then we can define, suppose model that we have used dot. Now from model we are going to specify the brand that we have specified earlier. So here we have defined the brand earlier, so brand has been defined. So here we are going to define brand, and then we are going to concatenate this with a simple space, and then we are going to add up the model name. So again, model name has been again defined as model dot, here we define model name, so model name. So this is going to be rendered, and again once we execute this, again this is going to be, so this is going to simply, you can simply create a build out of it, and then we can run the statement, and this is going to simply show us the entire output. So as you can see, once you want, if you want, we can simply run it, and here we have the property here, and then here we are seeing the same model that we have currently specified being returned to us as an output. Now let's proceed further on the other components available here. So after inheritance, we have something called as polymorphism. So when we talk about polymorphism, then it simply means taking many forms, literally. So where poly means many and morph means forms itself. So it is basically the ability of a variable, function, or object to take on multiple forms. So you can say, in other words, polymorphism allows us to define one inheritance or method and have multiple implementations defined. So we can take this, we can understand this by referring to a small real life example. So for example, we may have multiple bowlers. So now we may have multiple bowlers, and again we have defined a class with the name of bowlers itself. So let's consider this in real world scenario. So we know that there are different types of bowlers. That we have fast bowlers, medium pace bowlers, and spinners. So let's say if there is a parent class defined as bowler class itself. Let's go back to our annotation mode so we can understand this better. So let's say here we have a main class. Let's change the color of the pen. Let's say here we have a main class defined as bowler class itself. Now we know that now we have multiple types of bowlers available. Like we have the fast paced, we have fast pacers, then we have the medium pacers, and then we have the spinners. So we have now these all are going to inherit their own class from the main class defined as bowlers, correct? So bowler class has three different classes. We can say these are the three different childs of bowler. We have fast pace, medium pace, and spinners. Now the bowler class has bowling method, where all the child classes are inheriting this method. We may have a method defined here as a bowling method. We may have a method defined by the name of bowling. And now this method may be used by all the other child class as well. Now, as we all know that there's a fast bowler will be going to bowl differently as compared to medium pacers and spinners in terms of bowling speed, because again the entire way they are going to bowl is going to be completely different. So similarly, a medium pacer's implementation of bowling method is also going to be different. Same way, spinner is also going to bowl differently, correct? So the main idea here is that a same name tends to have multiple forms. So all of these three different classes above inherited the bowling method, but their way of implementation is going to be completely different from one another. And polymorphism in Java itself is used for handling these kind of situations. So basically, we have two types of polymorphism in Java. We have runtime and then we have compile time. So if we come back to our browser, so here basically we have two types of polymorphism. We have compile time and then we have runtime. So first of all, if we talk about the compile time, then in Java, compile time polymorphism refers to a process in which a call to an overloaded method is resolved at compile time rather than at runtime. So the method overloading is an example of compile time polymorphism. So method overloading is a feature that allows a class to have two or more methods having the same name, but arguments passed by to the methods are totally different. So unlike method overriding, arguments can differ in the number of parameters passed to a method. It can differ based on the data type of parameters and can also be different based on sequence of data types when passed to a method. It can be different things. So we can take a small example to understand how the method overloading works. So for that, we can come back to our IntelliJ. So let's say here we define a class by the name of adder. Now in this adder class, we had defined let's say, static integer, and here we define add, where we are going to create two different integers, integer a and integer b, as a part of the class that we are going to define here, integer a and integer b here. Now, once we are done, we can simply return a and b as and when required. We can return this as and when required here, and we can, to understand this in a much better term, or we can say, let's take the help of a simple example where we can make use of it. Let's take the example for any zoo. So let's say here we can define class as animal, and in the animal class, suppose here we have public void, and then here we may be using multiple animal sound. So now, not sound here, it's sound. So here we can define a statement as system.out. We have system.out.println, a new line, that means, and here we can define the message. So here we can define making sound, a simple statement. Now let's create another class. We suppose here we find class for dog, and this is going to extend animals as a part of inheritance. And then we can define public void. We are going to make use of animal sound that we have already defined here as animal sound. And now within the animal sound, we are going to define system dot out dot println, and then we are going to define the sound for, suppose, for dog. So dog makes bow sound, makes barking sound. Now, suppose here we can define dog simply makes dogs bark. And then once we are done, we can simply define the statement for some other one as well as a part of extending the same class with multiple child classes here. So now we have animals on, and they all have their own way of implementation. So the same way we can add for cat, the same way we can add for any other animal as well as when required. They all are going to have different implementation defined, right? So here we can define any other integration, and then we can create another class for defining those variations as well. So for example, here we can create another object, and then we can call the animal sound methods on both of them that is going to be applicable. So That's a simple example for polymorphism. After polymorphism, we have something called as abstraction. Now, when we talk about abstraction, now what exactly we mean? Now, you may have seen that there are multiple process that keeps going on in the background. For example, let's say when we make a call, then we see now, although we are seeing simply a call screen, but there are multiple lines of code being executed in the background. Let's say if we talk about booting up any device, now we may see just the boot screen, but there will be multiple processes running in the background, correct? So when we have this call, again, why we have this kind of setup, so that the users, they don't see the background process and they can just see the output without having any kind of confusion or any complex codes being shown to them. So abstraction refers to the quality of dealing with ideas rather than the events. It basically deals with hiding the details and showing the essential things to the user. So if we look at the, again, we can see we have multiple examples here. So here, if you look at the diagram, we have two different types of abstraction defined. So we have abstract class and then we have interface. So now when we talk about abstract class, then abstract class in Java contains the abstract keyword. So now what exactly do we mean by the abstract keyword? So if a class is declared abstract, it cannot be instantiated, which means we cannot create an object of an abstract class. Also, an abstract class can contain abstract as well as concrete methods. So we can achieve 0 to 100% abstraction using the abstract class. Now, to use an abstract class, we have to inherit it from another class where we have to provide implementations for the abstract methods there itself. Else, it will become an abstract class. So, as you can see here, it must be declared with an abstract keyword. It can have abstract and non-abstract methods, and it cannot be instantiated, and it can have constructors and static methods defined, and it can have final methods also defined here as a part of abstraction. And then we have interface. So let's say if we talk about the syntax for abstraction, then it is simple. So if we go back, we can see here, for example, let's say here we can define abstract class. Let's say here we define abstract class as mobile, and then we can define the abstract class here. So again, it can be any abstract class for mobile that we can define. And then within this, we can define abstract void run method. So basically, this is going to be the same abstract method that we are going to define here one by one as a part of simple abstract method. All right. And then we are going to see the implementation for it in next few minutes. And before we do that, let's also discuss on interface so we can combine them together. So interface is basically a blueprint of a class, or we can say it's a collection of abstract methods and static contents. Now, in an interface, each method is public and abstract, but it does not contain any constructor. And along with the abstraction, interface also helps in achieving multiple inheritance in Java. So we can achieve 100% abstraction using interfaces. So an interface basically is a group of related methods with empty bodies. We can understand interface better by taking an example for parent car interface with all of its related methods. So we can define a public interface for a parent car, and then we can define it as a part of interface where we can define, suppose here we can have for speed up, for apply brakes, for change gear, and then we can define the values in it as a part of simple abstraction here. All right. So now let's say if we want to work on abstraction as well, so we can take a small example for abstraction. For example, say we come back to our editor where we are going to make use of a simple class. So now to work on abstraction, let's say here we can define a simple class. Let's say here we can define an abstract class that we can define, suppose, as animal for the animal here. Now in here we can define an abstract method as well. So basically it doesn't have to be it can be a body, it can be any physical features of any animal as well that we are going to refer. For example, here we are going to define a public abstract void, and here we can define, suppose, as animal sound. Now, when we are defining an animal sound here, suppose here we can define public, void, and sleep. So now, how exactly they are going to sleep here? So again, for sleep, we can define any statement. For example, here we can define system.out.println, and then we can define, suppose we can simply add these as a part of sleeping sound, and then we can define a subclass for this abstract class, and we are going to allow the concept. We are going to also implement the inheritance as well. So here we can define class, and then we can suppose here we can define a class for, let's suppose, a pig. So here we can extend this from animal, and then within this animal we can define public, void, and then we can define animal sound from the parent class where we have derived this pig class from, right? Here we can define the class, and then we can define the statement as system.out.println, where we are going to specify the sound for a pig. So let's say here we can define pig is going to say, suppose here we have VB. So here we can define a simple pig sound here that we have inherited from the parent class. And then we can define any other class. For example, here, let's say we define class as my class. And here in the under my class, let's say here we define public, static, void, main, and here we are now the same main method by using the string argus. And then we are going to create the components here. Now, for example, suppose here we are going to create for pig, and for pig we are going to create, suppose, as my pig. Now here we can define a new pig object. So here we can do that by defining new and then pig method that we are going to create here. So here what we have done, here we had defined a simple new pig method and then as pig object. So once we define the pig object here, then we can define my pig, and here we can define the animal sound that we have defined, and then we can define the sound for what? Sound for the sleep. What sound does it makes? So this is going to be inherited from the above class that we have specified here, and that's how we are going to make sure we are inheriting these classes one after the other as per the structure defined. So now once we are done, we can simply build it for finding any kind of errors in case there is any, and then we can define, we can run it. So here we can see, here we have the sound and the actual sound being defined as a part of the output by using the concept for abstraction here. So now let's discuss the next component that we have. So next we have the concept of, so we discussed on the concept of inheritance, encapsulation, and okay, I think we had discussed on all. So we had discussed on, no, we haven't discussed on encapsulation. So let's discuss on what exactly encapsulation is. So encapsulation is basically a mechanism where we can bind the data and code together in a single unit. That exactly we mean by encapsulation. So basically, it also means that we can hide our data in order to make it safe from any modification. And the best way to understand encapsulation is to look at the example for any medical capsule. So we know that drugs are always hidden in the outer layer of the capsule itself, right? So the outer layer is only there to protect the drugs placed inside that capsule, correct? Capsule layer, and that's why the same concept is applicable in encapsulation as well. So through encapsulation, the methods and variables of an object are well hidden and safe from any unwanted modification. So now let's come back to our encapsulation method. So encapsulation is basically achieved by either declaring the variables of class as private, or we can provide public setter and getter methods to modify and view the variable values. So we can do both things. So as a small example, let's say we can come back and here we can use a small example. Let's clear the output. So let's say here we define a simple public class, and we can define a class name as employee, and then within this class, let's suppose here we want to define a private string name. So here we can define a private string name, And then we can define a public string where we can define a public string. Let's say we name it as get name itself. And then we are going to return the name. And here we are going to create public void set name where we are going to define string name component. And then we are going to define this dot name where we are going to define this for name itself. And then towards the end, we can define public static void main and string argus. All right. So what we have done here, so we have created a class employee, which has a private variable defined as a name itself. So here we have public class defined as employee, and then we have defined a variable there. So let's do one thing. Let's create a different class altogether by the name of employee. All right. So here we defined the public class as employee. So what we have done here, we have a class as employee, which has a private variable defined as name. And now we have created a simple getter and setter method through which we can get and set the name of the employee. And now using these methods, any class which simply wishes to access the name variable has to do it using these getter and setter methods. And then we are going to simply have a deploy. Thank you so much for joining and have a great day ahead. Take care. Bye bye.